Howdy folks, welcome to part 4, and today what we're going to do is get rid of this timer first of all. So we're going to get rid of this thing. I was messing around with it, and what happened, we need to get rid of all the references to it too. So we're going to go find all references. No? Okay, we're going to go like this, and we're going to find all in the current document. There we go. So yeah, we're going to get rid of all this. So I think what's happening is when this refresh runs, it basically takes priority and it overrides the thread that is trying to, because it's basically one thread or whatever, it doesn't want to multi-thread, I think. And so I don't know, maybe it's doing something else, but basically this refresh thing is taking priority and not allowing all the rest of this code to execute at the time. So we're going to get rid of any of the other references to this timer. Where is it? Why is it not showing me? There we go. Okay, so we're going to get rid of that reference there, and we're going to get rid of all this. And there was another thing down here. Yeah, we can get rid of this focus thing. We didn't need that, if you recall. So let me see. We're going to I think that's everything there. And yeah, I think that's everything there. So let's run that, make sure it still works. No, let's see. Let's form one, mouse click. Oh, I need to get rid of that from the form. Nope. Okay. And so, nope. Let's go like this. Let's go back to this. We're going to get rid of the mouse click. There we go. And let's see if that lets us. Yep. Okay. So now we've gotten rid of the timer. We've gotten rid of all that other stuff. Okay, good. So we should be good here. Now what we want to do is we want to make this thing just do a, we want to make this thing use our little rule set that we did last time to create a, rule. So what we want to do is we're going to do some coding on that. And so what we want to start out with is we're going to get rid of that, and we're going to uncomment this. So we're back to the point where now all the rules are going to be false. So if we just start this, see, everything's just going to be false. So there's not going to be any walls anywhere. All right. And so what we want to do is we want our rule set to follow a thing. So we're going to go string. Yeah, we're going to go string rule string equals, and I know I had a good one over here. Let me see if I can find it. It was this one here. I think this was the one that was really cool. So 0, 1, 2, 3. So we're going to have 2 and 3. And then 4, and then it's 5, 6, 7, 8. So it's 2, 3, 5, 6, 7, 8. We're going to go 2, 3, 5, 6, 7, 8. And then a slash, and then our other rule is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8. It's the same thing? Okay. So it's going to be 2, 3, 5, 6, 7, 8. Apparently that's kind of cool. It doesn't need to be. Okay, so that's how our rules are going to be entered in. So we're actually going to store all of our rules in an array that looks like this, and then we're going to interpret them out. So that way people can just paste that stuff in. And so this is good practice for string manipulation and that kind of thing. So the first thing we need to do is we need to separate this out into these two strings. And we should be able to go string, and we're going to do an array of them because it's going to return an array, and we're going to call sub rules, right? Sub rule equals rule string dot split, and we're going to split by a slash. And so that should do it. So when you specify a character, you want to use the apostrophes here instead of the other things. It almost looked like a little smiley there, didn't it? But yeah, anyway, so you want to use these. instead, the apostrophes instead of the or the single quotes or whatever you want to call them. Okay, so now when this is done, subrule is now going to contain an array. It's going to be subrule 0 is going to be that, and subrule 1 is going to be that. And so we're going to need to go through each of these. So we're going to go for I, int I equals 0. I is less than subrule 0 dot length, right? That's going to be the length of the string, and I plus plus. And so now we need to pull out each character out of here one at a time. And so we're going to go int j equals substring. Whoops, we're going to go subrule 0 dot substring. There we go. And then we're going to go I comma 1. And so this is going to take out, starting at position I, it's going to take out one character. And this is going to return a string. And what we need is an integer. So we're going to go convert, like we did last time, dot to int 16. And so that will give us our number from 0 to 65,535, which is obviously will fit because it's a one-digit number. So that should do that. And that's going to give us a number, and then we're going to go rule 0 comma j equals true. There we go. And so that is going to convert this into this, and then we should be able to do the same. We can even go for int k equals 0, int k less than 2, k plus plus, whoops, don't know why it did that, that was weird, k plus plus, and then we can do, oh, you know what, k is less than 2, k plus plus, and we can put our other one here, and then we can go subrule k, and we can do our subrule k here also, and we can even go like that, and then we don't have to duplicate the code. I mean, honestly, it's not that much shorter. It's just which way do you want to be lazy? And so this should now create that rule set. Let's see if it does. Just okay, that was interesting. We'll give it that. So let's see what we have as our rule set when this is done. Let's go check out our rule. And so rule false. Why does this seem, yeah, 2, 3, 5, 6, 7, 8, and then 0, 1, 2, 3, right? 4, 5, 6, 7, 8. So it looks like our rule set is correct. I'm wondering if that other, I'm wondering if this was not an actual, if this was an error in my output. Let me check and see if we're getting the same thing. Whoops. Let me check and see if we're getting the same thing for these. True, false, true, true, false, true, true, false, false. True, false, false, false. So this one is different, right? Yeah, I think this one was an error right here. Something's wrong with that. Let's see what we've got as far as the first one. 0, 1, 2, 3. So we have 4, 6, 7, 8. So let's try this one. We'll go 4. Whoops. We need to stop execution here. So we'll go 4, 6, 7, 8. And then the other one was 2, 3, 4, 6, 7, 8. Okay, yeah, I'm wondering if this is having, yeah, something. I'll bet all those rules that I dug up are not going to work well. Okay, let me try one more, because that doesn't seem to work. That doesn't seem to make sense. If they're all going to be like that, we're going to end up with stuff that's going to be weird. Here, let's see. Because it seemed, yeah, it was interpreting correctly. Let's just go like, something tells me that those were always going to end up either going all solid or all, you know, all solid in one direction or the other. So let's go 3, 4, 5. Let's try this one. Yeah, see, that's better. That's better. It's not going to be a very good one. And so I think we're going to need to find a different rule set. So why don't we do, okay, max ticks equals 20. Oh, you know what? Did I just hit a space in there? Yeah. So let's go like this, and let's try 0, 1, 2, 3, 5, 8. Whoops. And let's try that again. 3, 5, 8. And the other one is going to be 0, 5, 6. Let's try it. There we go. Okay, there's a decent one, and that one should allow us, I think that's one that's going to allow us a path through every time, I think. But just in case, I think I am going to go, I'm going to search for a better one. Is this doing just the reset? Is it? Apparently it's not randomizing the thing. Okay, well, I'm going to do that. I'm going to find a different, let me see. Let's go back down to, where is our make rule string, and knit blocks equals true. Oh, you know what? That's because we're not randomizing anymore. Okay, so let's do this. Let's go return. We're going to do that so that this code doesn't execute anymore. And we're going to swap this out. Okay, and we're going to have it randomize the rules again. And we're going to go and search through, do nothing. We're going to search through, and we're going to find a good rule set that one's almost okay. That one's pretty wide open, isn't it? Let's see if it stays wide open. It looks fairly wide open. Okay, so 0256 and 156. If we hit, is it enter? Is it enter that puts it in the output? Let me see, which one was it? Which key was it? Make rule string. And then, yeah, if we hit enter, it should write it in the console output. Where's our output? Let's see. Is it not right? Is it not? It's not intercepting that keystroke? It's intercepting this one. So why isn't it intercepting the enter? Let's try that. Okay, because of that button. It's doing the button instead. Okay, so now it's going to do it. Let's see. Yep. So we've saved that one. We're going to do one more. We're going to find one more that's a little bit more open, just in case. I want it to be fairly easy for our fairly easy for our AI to get work. Those are pretty cool. I'm going to save that one. Did it do it? Yeah. Okay, and then we're going to go like this. That's pretty cool. Try a couple more. That one's almost what I was looking for. You remember? Yeah, this is the sort of thing we want. Okay, so we're going to save this one. Whoops. All right, so let's, did I just lose our output? No, there it is, 2368057. Okay, so we're going to copy that. We're going to put it back up into here. Okay, and we're going to comment that back out, and we're going to double check and make sure that this works the way we want it to. There we go. Okay, so yep, now we should have a decent start. I think this should be fairly acceptable. Okay, and so what we want to do is, now that we're like 15 minutes in dinking around with this, what we want to do is we want to create the AI loop And does this ever get called? This never gets called, does it? Let me see. Nope, it never ever gets called. Okay, so we can get rid of this and we can do our AI stuff here. So what we want to do with the AI is we want to find player's position and create a target location to go after. So you basically you want to break stuff down into steps, and so let me see, and then we're going to go determine which of the 4 directions gets us closest to our target. Okay, so for each enemy, we're going to do this. Okay, and so we want to put in our variables for our enemy, and so we're going to go int, and we're going to go enemy x, and let me see, equals new int. What do we want to do? We want to do 4 enemies, I think. We'll start with 4. So why don't we do this too? Int num enemies equals 4, right? Or we can call it max enemies too. Let's go max enemies, and then we're going to go this. I'm going to see if it's going to let us do that. Good. Okay, so we're going to do, nope, it's not going to let us do it, is it? Okay. So we're going to have to do that when we run up the thing. So we're going to go enemy Y, and we're going to go target X and target Y. And so then we are going to initialize all of these. We're going to initialize all of these when we start up our program here, and so we're going to go like this. So we're going to go enemy x equals new int, right? That should work, and then we can just do that for all 4 of them. So we're going to go enemy y, and then we're going to go target x and target y. Okay, and so this will allow us to store our current things. I'm just trying to decide if we need another variable for the desired movement position. I think we can save that in the local thing. We don't need a big, we don't need something with that much scope on it. And the other thing, before I forget, we're going to move all these variables up to the top because it's just messy leaving them in the middle of all of this code. So we're going to go back up to here. We're going to put all of our variables up to the very top like that. Okay, so now we have them all initialized, and we're going to go for I equals 0, I is less than max enemies, and I plus plus. So for each enemy, whoops, if I can if I can select it, there we go. We are going to find our player's position relative. Basically, we're gonna figure out where our target wants to be. So the simplest one is going to be, we're going to start out with the simplest possible AI, and we're going to have the target be the player's position. So we're going to go target x I equals player x I. Okay, and so each time, we don't need that, each time y I equals player y. So yeah, when when each enemy is going to start out setting their target for that, basically trying to overlap the player. And then the other thing we need to do is check for collisions and handle collisions. So we're going to go, let's see, we're going to figure out, we're going to check each of the directions. Direction is closer. So we're going to go, we're going to call, let me see, do we need, I think we're going to go integer, yeah, integer x, temporary x here, and equals, and is that going to be a, yeah, I'm just trying to figure out if we want to do, we're going to do a distance calculation here, and I'm just trying to decide if we want to go up, down, left, or right, and figure out which one is the closest. So yeah, we're going to have to do, why don't we go up, T up equals target x minus our, where is it, enemy x. Okay, and that needs to be this one. So we're going to find our distance. I'm not sure if that's the way I want to do that, but basically we need to look at each of the 4 directions. For each direction, let's break this down in comments first, just because I need to lay it out so I can think straight. For each direction, we want to check, get a distance for each direction to move, that is, get a distance that will be from target if we move this way. Okay, so we're going to do that, and then we're going to, so this is going to be actually our distance. So we're going to go like that. If we move up, it's going to be enemy x minus 1, right? Yeah, that's what we want to do. So if we go left, let's go float distance up equals, and we're going to go target x I minus enemy x I, right? Those are going to be this, and then plus, and this needs to be squared, right? Do we need to do math.power? Yes. So this comma 2. Why is it not? Oh, is that going to return a double? Yeah. Okay. So that's going to return double plus, and we're going to go same thing. This squared, and we're going to do the y-axis here, and our enemy y minus 1. So when we're moving upward, our y is going to be up by 1, and so we want to check from that location. So we're going to put all of this in parentheses, and we're going to do a double here. We're going to force it to a double. I'm sorry, a float. There we go. I mean, we can just do double. Why are we conversing this to a float? Why don't we just do a double? There we go. Okay, so that's going to be our distance from our up. Like if we move 1 up to where our desired target is. And then we need to do this for each direction. So we're going to go down. And we're going to do the same thing, except our y is going to be +1. And then we're going to do the same thing for left. And we're going to have to make an ugly nested if-then, which some people just hate, but that's their problem. Okay, and so we're going to take out this. There we go. And we're going to do x -1, and we're going to put this in parentheses. There we go. And we're going to do the same thing here with right. Okay, so our distance right is going to be +1. So now we're going to we need to figure out which one is the closest. Check for collisions with background walls. That's the other thing we need to do, is we need to check to make sure that if it's moving that direction, we need to remember that, and then with player, because if that move gets the player, then, you know, obviously that's going to be an important thing too, if that lands them on top of the player. So we also need to go whoops, not sure why it's not indenting there. Okay, if we need to go target X, yeah, block, and then we're going to go blah, 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 and then we're going to go, if that's true, the one above us, then we're going to go distance up equals, and what is the, whoops, I do not remember what the, apparently it's going to allow us to, let me see how to specify a double in, let's see, how do we specify a double? C#. That is, where is it? D? Okay, is it a capital D? Like that? There we go. Okay, I just want to make sure that it knows it's a double. Okay, I like to specify those. Okay, so we're gonna go. What are we gonna do here? Our block is going to be enemy X, I, comma enemy X, Y, I, and then this is going to be with up, it's going to be -1. So we're going to do, whoops, not sure, I just hit page up again. I hate when I do that. I just totally lost my spot here. There we go. Okay, so we're going to copy this there. We're going to do that, and so this is going to be up is going to be -1, down is going to be +1. Whoops, it's down is +1. Why is it still complaining about that? Operator plus, huh? Okay. Oh, did I closed it at the wrong spot. Okay. I closed that at the wrong spot. There we go. Okay. Enemy Y -1. Okay. And then we're going to do the same thing over here. Left is going to be -1 and right is going to be +1. So this is going to be right, left. And so what we're going to do now, in order to find the one that's closest, is we're going to basically find the lowest number. And so obviously this is going to prevent it from being the lowest number. And if we happen to have all of these equal that, then we have a problem. Then, you know, basically the thing is trapped inside a box, and we'll probably just let it cheat and get out. But yeah, I don't know. We might have to make a condition for that later. But now we're gonna find which one. So we're going to go int, let me see, lowest. Yeah, we're going to go double, that is double closest distance equals 999. Let's see, let's just do this. D, okay, and then we're going to go if dist up is less than closest, then now let me see. So up is a candidate, right? So we've this is going to be fun doing this. And so I'm thinking we want to do it the other way. I'm kind of thinking we want to start this at 0 or even a negative. And we want to go if this is greater than. No, because we want to find the single lowest one, right? So yeah, let's switch this back. Okay, so if up is closer, then we're going to go closest distance equals dist up, and then we're going to continue on if dist down. So we're going to go like this. Down is less than closest dist. We're going to do the same thing. I know people are going to like freak out at this. Not everybody, but just, yeah. Okay. Distance down. And then we're going to go if left is less than closest distance. Then we're going to go same thing. There we go. And this one equals left. So we're going to have a whole bunch of cases here. If distance right is less than, then, okay, so now we've eliminated all 4 at this point. So what we want to do is we want to make a list of what's remaining at each of these. So we're going to go down, left, and right. We don't even need that. We can just do this. And then here we're going to have left and right that haven't been tested. And here we have right that hasn't been tested. Okay, so we're going to go, let's see here. We're going to go if, yeah, at this point everything has been eliminated. Right is the answer. So we're going to go let me see, we need a variable here. It's going to be int move x equals 0 and int move y equals 0. So basically, unless they have until they find an answer, we're going to start out at 0. So if this is the answer, then move x equals 1. Okay, now we have eliminated left and right. What we're going to do here is, since right is not the answer, we've only got left and right left remaining, that is. So that's actually this. And then this is that. So we're going to go else. And we're going to go move x equals -1. And this actually is one of those things where it seems kind of complicated at the beginning. Seems complicated at the beginning, but as you go it gets easier. And so now at this point we've determined that left, let me see, it's easy, right? So at this point, we've determined that distance down, distance left. Okay, so that is left and right remaining. This one has down, left, and right remaining. So down is not closer, so we still have left and right remaining. So we're going to go over to here, and we're going to go else. And so that is here. So we're going to do, whoops, we're going to do this thing again. There we go. And we're going to copy this. And we're going to go like this. And now since we determined that distance down is not closer, we're not going to change it to that. And so then we're just going to carry on here with our left versus right thing, as you see. Let's get rid of that too. And so now we're comparing left and right again. Okay. And that all is going to do that. And let me check this out, because I'm totally spacing out now. Trying to do this while talking. And so we're going to have to go, because I'm thinking what happens when the down is closer than left. Yeah, I'm going to have to look at this and think of it without talking, because talking really kills me. So let me do this, and I will get back to you in just a second, and we'll walk through it. Okay, so I finished this madness. I actually took a break and everything. And yeah, so I finished this madness, and you can see it's pretty crazy, and it's also fun to troubleshoot when you mess up something like this. Because you can't tell why something is moving to the right when everything just ends up in the bottom right corner, you know, something weird like that. You end up with some weird behavior. You end up having to go back through all of these. Now, I do not want to tell you guys that this is the only way to do this, because it's not. There's definitely another way to do this, and I wanted to show you that. The reason I like to do my logic like this, because it actually, if you look at this, basically none of these ever do more than 4 if statements, no more than 4 comparisons, so to get your answer. And so I'm just used to writing stuff in this inside of inner loops where it's running like, you know, many millions of times per second, and so it actually matters whether or not, you know, a few extra comparisons happen. So what I wanted to show you though is you can go like this, right? And you can do this sort of thing. You can go if up, you know, up is less than close, and up is less than distance whatever. Okay, and let's see, we'll just go like this. We'll copy paste this, and let's see, down, left, and right. Okay, down, and distance left, and distance right. Okay, and so you can do this, blah blah blah, else, if, and you basically do this whole thing over again. You just copy it, and then you change distance up to distance down, and then, you know, is less than this, is less than this, is less than this. Okay, and then this is going to be up. So if down is less than blah blah blah, and then you can do the same thing once again, else, if, whoops, and you go through this whole thing here like this. Okay, and so when you get to the end here, if none of these, you know, so you go up, down, left, and right, and so this will tell you where your left, whoops, and your right are. And otherwise there's no valid move, so you would go like no valid move here. So that's going to be what's going to happen in your F. So if you do this, so if it's your right thing, you're going to go like that. If it's your left thing, you're going to go like this. And obviously you're going to need to change these, and I'll show you this, left, 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 and we'll do this same thing here. You can do a find and replace if you want to do it that way. And we did up and down, we did left. I love that it highlights this, and so now you got to worry about, you know, are you comparing left to itself? So up and down, right? Up and down and right. Left is going to be compared to up and down and right. Down is going to be compared to up and left and right. And right is going to be compared to up and down and left. So there you go. You can do that kind of thing, and you can do your move Y here. So if it's going up, it's going to be move Y equals -1, and if it's moving down, you're going to go move Y equals +1. So yeah, you can actually code all of this in, like, you know, just that much time if you want to. And I will actually leave this in the source that I'm gonna put on the Git, so that if you want to do it this way, you can. It's just, you know, and it's nice if you're getting bad behavior on this, you can actually comment this part out and uncomment this part, because you know this is logically sound. It's not a logic error. And so if you are getting a logic error, then this is going to tell you, you know, if your behavior suddenly fixes itself when you swap, then you know you need to go through these if you want to do it this way. Like I said, you know, there's other ways to do it too. You could put it in an array and do an array sort. But we're just going to do this. And one other thing we need to do is we need to go, if we already did collisions with walls, we need to go, because we did that up here. So yeah, we did that when we decided to do that. Okay, so the other thing we need to do is we need to account for if the enemy is trapped. And so what we're going to do is we're going to go up to our variables, and we're going to add an integer enemy, trapped 4. It's no, it's just going to be that. And then we're going to go, I always do that. It's the old habits. Okay, so we're going to do that, and we're going to set this enemy trapped. There we go, equals this, equals new int max enemies. Okay, and so that's going to be 0, and we're going to count up, and so like we're going to go like this, enemy trapped ++, and what is that, I? Is I the number of the, which is the number of the, yeah, I is the number that we're using for our iteration here, and ++. Okay, so later on we can check if enemy is trapped, handle this situation. If it's not, that's fine. It doesn't matter. For right now, we don't need to worry about it. But we'll put in our thing so that we can do that later. Now, the other thing we need to do is, let's not worry about the collisions with the player yet. We did handle collisions with the walls already. And so what we want to do is we want to draw where they are so that we can watch them and see if the AI is doing anything. And so what we're going to do also is we're going to go enemy x plus equals move x, right? And we need to do that. And then we're going to go enemy y plus equals move y. Okay, so then we're going to actually apply our movement, put the enemy in the new found better position. Okay, so right now the target is always just going to be the player's position, so we're just going to chase the player pretty directly. All of them are. And so what we're going to do here is, where is the, let's go into here and we'll go repaint. And so on here, what we're going to do is we're going to go like this, and I think we're going to do these all individually. So we're going to go yellow, and we're going to go enemy X 0, and then enemy Y 0. There we go. And then we're just going to go like this, and we're going to go 1, 2, 3. Okay, and so we're just going to hard-code the colors for the moment. Let's go blue. What do we have? Green as a player. Yellow, blue, orange, and yeah, red. Yeah, sure, we'll do red. Okay, and so now we should be able to see where the enemies are each time. And do we actually have them moving now? Is this actually being called? Let's find all references, and are there any? Nope, there are no references. So we actually need to make that call main loop. Let's go back to here. And the other thing we want to do is, before we do that, we want to go enemy timer. Okay, equals 0. And so what we're going to do is when we go through this, we're going to go enemy timer plus plus, whoops, and then we're going to go if enemy timer is greater than, let's say we're going to move them once per second, so 30. Then we're going to go enemy timer equals 0. We're going to reset our timer. And so actually we're going to go 29, right? If we want to do literally 30. And then we're going to go main. What was it? Main loop? Yep, main loop. There we go. And I think that'll do it. I think that'll do it. So let's try running this. Save what we've done and try running it. And see what happens here. There we go. Oh, we got some kind of an exception. Index was out of range. Which index are we looking at? I can't tell. I can't tell which. You know, it actually kind of annoys me that it doesn't tell me which. Let me see. Does it tell me which index? No. I don't see the name of the variable that it's trying to do. So let's close this, and you know what? These guys were at, we need to set their positions is what we need to do. So when we set up the map init blocks, we're going to set up, let me see. No, that's init blocks. We want to do, where'd that go? Not that one, set roles. So yeah, whenever we reset all of this stuff, I think we want to reset enemy positions. I think that's where we're going to call every time. Yeah, that's where our reset is going to be. So we're going to go enemy X equals 10. So we're gonna put them at some different spots here. So we're gonna go like this. Let's see, 10, and what should we do? 10, and we'll go enemy Y 0 equals start at 10, 10, and yeah, let's do. I think we can. I'm just putting these on the same line. Just it makes it a little bit easier to visually see what we're doing. Whoops. 1, 2, and 3. So we're going to start one at 10, 10. We're going to start the other one at 20, 10, 20, 20, and 10, 20. Let's do that. And is there anything else that's going to be... Nope, I don't see anything else. Okay, so let's try this and we'll see. Huh. Not set to an instance of an object. Okay, it hasn't been initialized yet. All right. Yeah, enemy X has not been... Are we setting the rules before we even... Let me see. Are we setting up the rules before we even get to the... There, and there. Blocks. How is that going first? Apparently it is, though. Huh. Okay, so let's put this back down in here. Let's go like this. Let's just make a function for this, and we'll do it outside here. So we're going to go private, not even void init enemies, because we might want to call this from other places too. There we go. And then we can go like this. Copy this here, and so now that we know they've actually been initialized when we do that. Okay. So let's see what they... Yeah, there we go. Check that out. Now they're coming at me. There we go. So the blue one is trapped. The orange one is trapped. I'm not sure why they're trapped. So we will have to test and see. Now he's going to come down there, and then he's going to be trapped, right? Nope. Yeah, he's not going to know what to do, is he? Okay. So we're going to end up having to... That's pretty cool. I might want to speed them up just so I can see better, a little bit better, what they're doing. But yeah, so we're going to have problems with them being trapped and stuff, and we're going to start troubleshooting that next time, because I think we're probably running pretty long today. So that's going to be it for part 4. So join me in part 5, and we will start trying to work out the logic on these and get them, you know, doing some not quite stupid things, trying to chase us through the maze. So yeah, that's going to be it for part 4. We'll see you guys in part 5. Later.